What is the derivative of ln of x? Logan.
Yes!
What is the integral of 1 over y dy?
Oh, yeah. I don't remember.
Isa.
Yeah, so you see.
It is a plus c at the end.
He said.
Oh, that's not what you were saying. No.
Oh, yeah.
Chris,
Yeah,
do you know?
He said plus C.
Plus C, it's something plus C.
Yes. Okay. What's the integral of 1 over y minus 2 dy? It follows the same pattern.
Would it be y minus 2?
LN.
Isabel.
ln of y plus c. I said it right the
You
first
got it.
time.
Yeah.
Why
There
are
you
you
go.
looking at me like it was wrong?
Okay. Yeah. So you know for the chain. So guys, you know for the chain rule, the inside stays the same.
It does?
Yeah. So like y minus 2 is the inside. It stays the same. See how it's the inside,
Yeah.
and it stays the same. It's like you don't change the inside ever. Oh, we're not going to do this one, but see how it's minus y, it would just be the same but negative, but we're not going to do that one. Okay. What is the derivative of ln of absolute value 2x? Think. Chris. What about the derivative of ln of 3x? Logan.
Oh. 1 over X.
What about this one? Think. I am still calling on people. Isa. Isabel.
3 over X.
Oh, when it's okay.
Mariam.
4 over x. I didn't understand the
Yeah?
this one. but
Oh,
I
yeah.
just got it.
This one, yeah, good. This one again. Isa.
X plus c. ln of x plus c.
Correct.
You have to mention the absolute value.
You should, but it's cool.
You should?
It's fine.
So
Don't worry
how do you
about
read
it.
that? I don't know how to read
ln of absolute value of x plus c. Good clarification. ln of absolute value of x plus c. All right, now this one, this looks similar to that, right? But it's a completely different strategy. This has nothing to do with ln. This one, ln. This one, not ln. What's the strategy? Raise your hand for this one. If you think you might know. Chris? Yeah. Okay? So if you have a degree that's not 1 in the denominator, you're most likely going to rewrite it as a negative exponent. Remember that? Yeah. From back in the day? You rewrite. Okay. We did it with derivatives, not with integration yet, but you can apply it. Oh, what about this? How can I rewrite this, first of all, before integrating? Logan, I want you to pay attention to the way from. Before integrating, how can I rewrite it? I'll just take hands at this point. Nope. That's correct, but that wouldn't help me. So this constants are great to pull out in front, so that way you can like ignore them. So I'm going to rewrite this as 1/2 the integral of 1 over x dx. So constants, if you can pull them out, pull them out. Because what's the integral of that? Just a half ln of, right? Does that make sense? That's how you would do it. Yep. So the 2 on the bottom didn't, just made it a half in front, right?
What are you covering?
This is equivalent to that.
Oh, there's.
How?
Because
Power rule. You can put that there. So you have ln of absolute value x to the half, which is the square root. No, the absolute value is the square root. Okay. What about this? How am I going to rewrite it? Don't do it. How am I going to rewrite it, Isa?
You bring it out at 1/3.
Yes. Now, what's the answer, Mariam?
It is, this, wait. If it's x plus c, then it's 1/3 ln of x plus c.
Yes. Nice.
I could see it in my head, I didn't know my finger.
Good. Oh, right. I know but that is a good point. That one of the reasons I do pepper is it is important to be able to read to say it.
Because then it
So I'm glad we're
really
practicing.
A lot of these, I can read them in my head right now.
Yeah. And that is so. APQ 2. This problem has a lot going on. I start with U substitution. So what is my U going to be?
X squared plus one.
Yeah. So U is usually the denominator. Another rule of thumb is U would be the part with the larger exponent. Okay, so U equals x squared plus 1. Let's just do this together as a refresher. Du. What's du? What's du, friends?
X.
2x.
2x. Because it's just the derivative of this. Don't look at the problem, just look at this. 2x dx.
How come it's du instead of like more than I
It's not, because there's no quotient rule for integration. The quotient rule is for derivatives. I'll say that again. Basically, actually, I'm glad you brought up quotients though. So basically, the quotient rule for integration is U substitution. Yeah, kind of. Or like how you integrate quotients is U substitution. All right, let's substitute. So I'm going to integrate. I'm not going to put the 2 and 3 here. We'll talk about that. Not yet. So I'll just call that done. The bottom is
It's very the same.
it's gonna, but I'm substituting. U. Logan, you awake there? She's kind of awake. All right, and now I'm going to substitute for x dx. So over here, I'm going to solve for x dx. So if du, this is like one of the key steps of U substitution, is right here, solving du for what's in the problem. So if du is 2x dx, what's x dx? Lisa? Nope. Like, how do I get rid of this 2? What do I do both sides? So I'm going to write it as a half du. And I can write my half anywhere. I recommend that you put coefficients out in front. And then you can put your du anywhere. Do you like du over u or 1 over u du? Do you have a preference? Do you have a preference between 1 over u du or du over u?
Not really.
I put U.
So that is the U sub. What?
You put the dx.
We're going to put the x's back
How
in.
did we go like that?
How did I get 1/2? Spell that back. So I divided by 2 on both sides, or like multiply by a half on both sides? Okay, so now what's the integral of a half du over u? Let's actually integrate.
1/2
ln u.
Yeah, great.
plus c.
Yep. So this is going to be a definite integral. So I'm not going to put the plus c because remember how it's going to cancel out.
Yeah.
So now I'm going to put my x's back in. All right. 1/2 ln of x squared plus 1. This is an absolute value sign, but do the vertical line to keep track of my limits of integration now. I'm bringing them back from 2 to 3.
Why do we use absolute value for that?
Because you can't take the natural log of a negative number, so you have to. That just ensures that the argument is positive. All right, you ready to plug in? Which one do I plug in first? The top or the bottom? Bottom. Okay, so 1/2 ln of absolute value of 3 squared plus 1 minus,
Bottom is 3.
what?
The bottom is 3.
No, you do the top first.
Oh, you said bottom.
Oh, excuse me, yeah. Plug in top minus substitute in bottom. Do you remember that? Substitute in
Yeah.
top minus substitute in bottom. 1/2
Did I miss that
ln.
whole thing?
I don't know. I mean, if one person knows it and you didn't, it sounds like you missed it. It's just called the fundamental theorem of calculus, so.
Oh, wait, maybe we didn't do an example.
We didn't, yeah. We didn't do an example. You know how we did capital F of B minus
Yes.
capital F of A?
Yes.
So B is the, yeah. So this is my capital F of B being 3, minus capital F of A being 2. Are you ready to simplify here? Alright, let's go. She's been sick for like a week.
She was here yesterday.
I know, I'm very sick. Did you see her? Okay, so I'm going to take away the absolute values because we know 10 is positive, okay? So I'm just going to write 1/2 ln of 10 minus 1/2 ln of 5. All right, let's look for our answer. Okay, let's remember log rules, okay? This is why we,
You divided me.
yes.
Oh.
The difference of two logs is log of a quotient, is what I like to say. The difference of two logs is log of a quotient. So I'm right here, so I'm just, notice how I pulled out the half just for clarity. I'm not gonna worry about it. Like, it's gonna have a half out in front. It's gonna be A, B, or E, okay? So this is the difference of two logs. I rewrite it as one log, ln is a log, of a quotient. Actually, I don't need these parentheses, they're kind of confusing.
I've come to the conclusion that I'm a great guesser.
Yeah,
Because I like to guess which one it's going to be before we do it.
yeah, okay.
I've gotten the last 3 ones right.
So I think in some ways the AP exam is harder now that there are 4 choices than when there used to be 5 choices. Because with 5 choices, typically like 3 are the same, and then 2 are this, you know, like 3 have a half, right?
Yeah.
And 2 don't. So like you want to go with the one that like is the most, has the most commonalities with all the other questions.
Wait, so there's
That's
4
my strategy.
questions now?
Yeah, there's only 4 choices. So most of the time it's like 2 and 2. So you can't like look for commonalities. Yeah, a few years ago it changed to 4 choices. Okay. All right, you ready for this one? We're gonna do this together too. This is a classic problem. Well, the 2x makes it extra hard. We've been doing quotients, right? Like this isn't a quotient. There's no denominator. I've been.
Wait, so which one is the answer? Oh wait, so it's 1/2 ln of 5?
No, it's 10 over 5.
This is part of it.
Oh, so 1/2 ln of 2.
Yes. Do not make it that far yet. Okay. This is. I have to rewrite this. How can I rewrite tangent? Any trig identity remembers? It's sine over cosine. Sine over cosine. So I'm going to rewrite this as an identity of sine over cosine. So every time you integrate tangent, you have to do it this way. Okay? There's no like memorize. You know how like for the derivatives we just memorize each one? The integral of tangent is like a process. It's not something you memorize. You have to say, how do I derive tangent? I rewrite it like this, and then I do substitution. Okay. I'm going to rewrite it as the integral of sine of 2x over cosine of 2x dx. All right, ready for use substitution? Use just going to be the denominator. Can you please find du? Did you get negative a half du equals sine of 2x dx? Okay. Want to do, what's that?
Oh, why is it negative 1 time?
So you're solving for 2x, sine 2x. So you want to get rid of the negative 2. So I divide by negative 2 on both sides. All right, do the u sub. Sub it in, and then integrate if you can. So if there are numbers here, it's a definite integral. That means you're going to plug in the top, plug in the bottom, and the c's will cancel. No c's necessary. But if it's an indefinite integral, I do need the c. Okay, we're this far, hopefully. And then what's my answer when I put u back in? B. It's the one with the negative half. I would say, can we just like look at some multiple choice strategy real quick? See how right here I saw there was a negative 2 in my du, right? There's no negative and no 2 out in front of my problem. So that means there's going to be a negative a half out in front. There is only one answer with a negative half.
So we don't even have to solve it.
I mean, yes and no. I mean, sometimes like there could be a denominator that changes to a negative exponent that would cancel that out. You never really like know if something weird's going to happen. But mostly that's pretty solid. Okay, average rate of change. We know how to do average rate of change, right? What's the formula for AROC? Okay, we're moving.
Over B minus A.
So that is our formula for AROC. All right, so here's my function. Here's my A and my B. Sub into the formula, just like find the slope. Right? Yeah, we need to group up here. Okay, so this is 4 minus 1 on bottom, right? So if I were guessing, there's only like one answer I would guess, C. Because it's the one with the 3 in the denominator. But let's see, I don't know if it's C or not, I don't know. Now you can't plug in here because this isn't f of x, this is dy dx. It's not y, correct? So if dy, here's my question, if dy dx equals 1 over x, what's the function y? So ln of x. Like this is the derivative of that. So, and then I can plug in ln of 4 minus ln of 1. What's ln of 4? I don't know. I'm going to leave it that way for a sec. What's ln of 1? 0. So this
is ln of 4 divided by ln of 1.
You could change it at no. So a difference of 2 logs changes to 1 log. This is the log rule. Not ln on top and ln on bottom. ln of top one. You with me? Now why, the answer is C. Why is the answer C? Because I can change 4 to 2 squared.
You expect us to think about like that?
So I will say, this is an older problem. I will say on the newer exams, there are a lot fewer pre-calc log rules / they're not so much there.
You can't just give us the answer that we're gonna find.
I know. Yeah. So I'd say this is like a little, they don't do this as much anymore. But yeah, it's pretty rough.
If you gave us a problem like this on our test,
Yeah.
can you just imagine the reaction?
Oh my gosh. It would be like
If the
less
answer
than
was
a fifth.
no.
Correct. Yeah.
Yeah.
Although this one, again, you could kind of, I mean, you're
I know.
surrounded by 3, right?
I know, I'm just-
Yeah, but yeah, it would be bad news. Yeah.
Just do it as extra credit and then we'll get it right.
Yeah.
Yeah. I'll remind you, don't worry.
Love it. Okay, let's read the next problem. Isa, can you read it aloud?
Alright. No, the average value of 1 over x on the slope table 1 over 3 is.
Okay, so this is a new term. We have not learned this term. We're going to learn it in regular class. It's a formula. For now, we'll just think of it as a formula. I'm just going to tell you. Okay? The average value is 1 over e minus a times the integral from a to b of f of x dx.
What's that?
That is average value. Average value. I have a whole proof for it. We'll do in class, hopefully, maybe. That's the average value. So A is 1 and B is 3, right?
Yes.
So here's what you're going to do. You're going to plug in the 1 and the 3. F of x is 1 over x. You're going to integrate and do the thing where you substitute in the upper limit of integration minus substitute in the lower limit of integration. Go ahead.
LOL.
I agree, it's D, but before I did it.
Yeah, all right, so we're here. We have a half integral from 1 to 3 of 1 over x dx. So I have a half.
Oh, this kind of makes sense.
There's this cool thing with brackets you can do where to keep track, instead of doing the vertical line, you can, if you want a thing out in front, I won't do that, it's too much. So 1/2 ln of x from 1 to 3, so a half ln of 3 minus a half ln of 1.
Oh.
ln of 1 is 0, so it's a half ln of 3.
Wait, question this.
Yes.
So
Where do you get 1 over
you can't
3?
do like 1/2 ln of 3 over 1?
You totally, yes!
Because won't that get you the same answer?
Yes, you can do that.
So you know how the other one we like divided ln of 10 divided by ln of 5? It's ln of 3 over 1.
That's what I did.
Yeah, me too.
Yeah, that's easier sometimes to just like do that process than like remember that ln of 1 is 0. Yeah. Love that. Love that. Connections. Okay. No. Okay, so we're skipping APQ6. Yeah.
Yeah.
And you're going to do this one.
What?
What?
Aren't you funny?
Alrighty, the integral from pi over 4 to pi over 2 of cosine x over sine x dx. You did a problem similar to this. You started by setting u equal to the denominator, yeah? Alright, go from there. Let's all group up. Let's all group up. So you get ln of u. Alright, so you get ln of absolute value of sine x. If you made it that far, like that's actually like a lot of learning and complicated stuff. So that's good. Of pi over 4 to pi over 2. So you substitute in, so you get ln of sine of pi over 2 minus ln of sine of pi over 4. Yeah?
Yeah.
Sine of pi over 2 is 1. So you get ln of 1, which is
Oh.
0,
That's what
minus, this is ln of root 2 over 2. Okay? Now I assert from here
That's what I did.
that you can probably guess the answer, even though it's uncomfortable because you got a negative and none of them are negative.
That's literally what I got.
So this, the only like numbers here are 2's, right?
Mhm.
So what do you think would be your guess? Yeah,
Why
it is
is it
gonna be
A?
A. Why is it A? So I'm gonna work a little backwards. So I'm gonna take,
Why can't they just?
okay, I'm gonna raise
Wait,
this.
doesn't it become ln like square root of 2 minus ln of 2?
Oh yeah, we could do that. But that won't help us get, okay, so this negative, yeah? I can move it up front as an exponent?
I did not know that.
You could do that? Oh, I
Sure. I mean, the things out in front you can move up as exponents. So like 2 ln of 3 is the same as ln of 9. It's a power rule.
Interesting.
Remember how we did like a half, at the beginning of class we did a half ln of x and changed it to a half root x?
Yeah.
Yeah. Again, I think that these rules is like not the AP style anymore,
Okay.
but I do like it because I want you to know log rules. I do. Not for the AP test necessarily, but like I want you to know log rules. So this is, okay, so this is ln of root 2 over 2 to the negative 1. Yeah? Raising something to the negative 1 means taking its reciprocal.
Oh, I thought you were making a fraction.
It's like you make it, it's like 1 over. You make it, like raising something to negative 1 is,
Oh yeah.
I could explain, like,
Like 2 to the negative 1 is 1/2, right?
right, if you have like 4 to the negative 1, that's 1 over 4. It like
Yeah.
moves it to the denominator, right?
As long as it's 4 to the negative.
So, let's ignore the ln. Let's just like, so this is 1 over, so root 2 over 2 to the negative 1 is 1 over root 2 over 2.
So question, if it was to the, like, if it's like the negative 2, it would be 2 over,
No, it'd be 1 over that squared.
Wait, so then how does that equal ln of?
Yeah, let's keep going. It's going to be a few steps.
okay.
Stay with me. I know it's, okay. So I'm going to multiply by a form of 1. So this is how, this is like the actual correct way to show multiplying, dividing, simplifying a complex fraction. This is a complex fraction, right? So to simplify it, I'm going to multiply by a form of 1. Why? Because that doesn't change it, yeah? So my form of 1 is going to be the reciprocal of this, 2 over root 2, under itself, 2 over root 2. Do you agree that this is 1? So I'm not changing it. So I take the reciprocal of the denominator, and I put it under itself. So what's the denominator multiplied to? 1, which is what I want. I want no more denominator. This is good. Yeah?
Yes.
So denominator gone. This is just 2 over root 2. Yeah? Now I'm going to do something called rationalizing it, which again, you're supposed to learn in pre-calc. I'm going to multiply by a different form of 1, the denominator under itself. Okay?
I'm pretty good at the
Yeah, just watch.
Okay, it's fine.
Just watch.
Dreading.
So what's 2 times root 2? It's 2 root 2.
2 over 2.
What's root 2 times root 2?
Root 4.
Yep,
Oh, which is 2.
which is 2. Root 4, which is 2. What's this simplified to?
Root
All
So,
of that.
2. Oh.
the reciprocal, or the, so that's where the root 2 came from, and that's why it's positive, because I put the negative in the exponent. When I put negatives in exponents, that makes denominators, it makes the negatives go away.
Want to take it?
Yeah.
How did you put the negative on that one as an exponent?
What?
How did you get the negative 1 as an exponent again?
So because I was subtracted, the fundamental theorem calculus, I plug in the top minus plug in the bottom. So remember how it was minus ln of sine of pi over 4? So it was minus ln of root 2 over 2.
Yeah.
So that minus in front, I moved to a negative 1 as an exponent.
Can you just always do that?
You can always do that. I don't know that you always have to, but you can always do it, yeah. With log rules, students want to know like which one's simpler, which one's the most simplified, and there is not an answer to that. They're just equivalents, you know.
Yeah.
I don't understand why they can't just write the right answer.
Miss, can I take this?
Can you? Yes, I'm gonna.